Yeah. Hello all, and so welcome to today's webinar on robotics. Okay, so this is introduction to robotics module in Automation Studio in version 9.0, right? So this webinar will be an overview of robotics, not a detailed webinar, right? So it will not be a detailed webinar because it is just an overview. It is just an introduction so that you will be aware of like what all or things included in the robotics module in Automation Studio software. Okay, so like our brochures are updated. You can check the professional edition brochure. So educational, I don't know if it is updated, but this is the professional edition brochure. You will find the new features in that. So we have introduced two library in version 9.0, that is the robotics library 1, and the other one is the instrumentation and process control. Okay. So I will go little slow. Okay, I will. Okay. So I will just go little slow. If anybody has any questions regarding the robotics, okay, or any question, so you can just type that question in the question pane, right? So maybe in the between of the session or at the end of the session, I will try to address those questions. Okay. So as I told you, like this webinar is it's just an overview of the robotics. So here in the version 9.0 in the robotics module, um, so we are going to introduce the robotics catalog. Okay, so we will see the work cell visualization, robot control panel, motion program manager, how to give a motion program to a robot. We will see the complete work cell and different technologies combined. Specifically, I will show you for PLC. One example I will just show you, and I will show you the monitoring during simulation. Okay, so these are all some features which are added in the robotics module, right? Again, this is in developing stage, right? With the updated versions, you will get more features in this library, um, right? So there will be some doubts at the end of the session, like how it will be done, how this feature can be done. Okay, so maybe that cannot be possible in this version, but in the coming version that will be definitely possible, right? So you can look at this brochure, and in fact for the prospects you can just show them this brochure so that they will understand about the robotics library, right? So I hope you all have upgraded the version to 9.0, right? If not, please update it because it will give you a better idea about these two libraries and other features, right? And it will be like um, also useful for the like for your demos. Okay, it will you can show this version to your clients and prospects, your customers, right? Okay, so I hope the screen is visible to all. So this is the interface of Automation Studio Professional Edition 9.0. Okay, so I have not opened the educational edition because I wanted to open all the files. Okay, I wanted to show other files also. Right, so that is why I'm showing it in professional edition. But for robotics library, it is same in educational edition also. Okay, just the only things are like there will be some limitations in the features. Okay, so that you can check it. Otherwise, all other libraries same here. So here you will get the instrumentation and process control library. I will just give a okay, brief about this. You can see all this. You can check this libraries, measuring instrument valves. Okay, contact with liquid, other things. So maybe later we will also organize one dedicated webinar for this instrumentation and process control. Okay, but today's is for robotics. So if you just click on robotics library, here you will find all the um, components or the tools associated with the robotics module, right from robots. Okay, all. So we have 6 axis articulated robot and 4 axis SCARA robot. Then we have these tools for now: cylindrical tool, conical tool, then suction tool. Then we have loads. We have prismatic load, cylindrical load, and spherical load. Then conveyors. Okay. Then sensor also: linear conveyor, curved conveyor sensor we have. Right. Now, in order to um, draw or create any, you can say the diagram, robotic diagram. Okay, we need a robot um, workspace. Okay, robot diagram sheet. Okay, so you can say, so you can just go to document here and you can just click on robot diagram here. Okay, so it is, you can draw a robot diagram in a this worksheet only. Okay, workspace only. Right. So when you just click on robot diagram, right, so this kind of interface you will get, right, a grid view you will get. Okay, where you will get an axis. Okay, x-axis, y-axis, z-axis. Right, you can check this axis with the this interface. You will get a 3D manager where you can monitor your robot. Right, you can monitor your robotic assembly, so you can view your robots, loads, and machines here. And here in the ribbon bar, one more tab will be added, that is robotics, right? And here you will get different planes, okay, options. If you just click on robotics, here you will get um, robotics standard. Okay, you can check this, where you can change the appearance, colors of the joints. Okay, constraints. So you can look at this. You can also give the motion program manager, which I will show you, then the control panel, then the conveyor. Okay, so all these sections you will get, which you can explore. Okay, so in this interface, you can, it is very easy, like other how we used to create one any hydraulic or pneumatic circuit. Likewise, you can just drag and drop this robot here in your workspace. Okay, like this, you can drop any robot, right? You can drop these robots. And so this is like 6 axis robot and 4 axis SCARA robot. When you're dropping this robot, so they are fixed to your in this workspace. Okay, you can check this dark blue base. Okay, dark blue color base, so that means your base is fixed, you cannot move this robot. Okay, you cannot move this robot here. If you just right click on this, you can see here fix. Okay, and the right, it is already checked. If you just click on this, so your robot is now movable. Right, you can see similarly this one also, you can do this, right? Similarly, if I want to, okay, I will not fix this. Also, you can click on this robots. As soon as you add your robot here, your robot will be reflected in the 3D manager. Okay, it will be reflected in the 3D manager. So you can see here. Now, as soon as your robot is added, so you will get two options here again, the tools and the user frames, right? So you can check this. So when you will add the tools will be reflected in the tools. Okay. Now, if you just double click on this robot, you will get the properties associated with that robot, right? You can check the envelope transparency, robot simulation mode like kinematics, dynamics, You can check the maximum linear speed, payload, okay, number of digital inputs, outputs, right? References, okay, robots, mass, okay. You can also display the 2D and 3D envelope outline. So if I just click on this tool center point, okay, so you can check this work envelope of the robot, right? So this is the work envelope of your robot. You can check this, okay. So I will make it none again. Then again, there are different joint angles. Okay, you can edit the joint angles anytime, which I will show you during the control panel. Okay, again, you can name your robot. Okay, for example, it is now 6-axis articulated robot. I will just name it as, okay, robot robot one. Right. For now, I will just name it as. So this is like component name. You can give the outline name also as robot one, and you can display this name here. Okay, so this we do not need it, right? And you can check it, and more details you can check the details here. See, this is visible here, so it is robot one. Okay. um Now, if you just click on this robot, right, you can see the control panel is visible here. So I can just click on this control panel, right? So with the help of this control panel, you can give the manual transmission to this, or the manual motion to this robot, right? So for with this control panel, you can just check the motion. Okay, you can edit the motion of your particular robot. So here, um, you can see different modes, like you have different joints here, right? You can edit the joints. You can have to select the. You can just with the help of mouse cursor, you can give the motion here, so you can see in this way. You can give the motion. Also you can edit it here also. Okay, here also you can just edit this. Like for example, I want to give 90, you can just edit this, right? So you can just edit these joint angles. If you want to use the Cartesian method, so you can also give the you can edit the your parameters using the Cartesian method. So this will be edited with respect to your base, okay, robot base, right? Again, there are like two home positions here, home buttons. If you check, if you just click on the reset all robot joints, so it will be reset, it will be into 00, right? And there is another home button. It will make you in the position of like use position. Okay, when you have to use the robot, it will be reach you to that use position. Okay, so this is one feature. Again, there are like dragger mode. Okay, so you can just check the dragger mode. So before that, I will just close this control panel, and I will add a tool. Okay, I will go to tools here. So you can edit, take the tool, and take the tool in this tool section. Okay, so here in the tools also, like I have added the tool. If you just double click on the tool, you can give the center of gravity to this tool. Okay, you can change the function of this tool, height, mass, and radius also you can change it. You can change the orientation, like tool center point orientation, tool inertia. You can change it, right? That you can change. Even you can change the tool directly in this way, right? Now, here also you can like give the loads, right? If I want to give the prismatic load, you can give the prismatic load here, right? Prismatic load, cylindrical load, then spear. Okay, this way you can just give the load. You can change the color of the loads also. If you click on this box and then click on edit tab, you can choose your colors in this way, right? You can change it to any color for your identification, and here also you can change the like size also. You can give the size as per your requirement. Okay, yeah, I hope it is clear till now. If you are creating it with me, okay, I will wait till now. If you have any doubt, you can ask in the chat box, right? Okay, so I will consider this as like you all are okay till now. uh, Now as I was there in the control panel, I will go back to control panel again. We'll go back to control panel, and I was explaining the dragger mode. So we have two types of dragger modes here. You can see, you can check this dragger mode. Okay, here you can just take this dragger mode. Okay, to reach your robot to a particular destination, you can just check the dragger mode, right, in this way. Then we have this one also, dragger mode. You can just zoom is. Okay. Mm-hmm. Yeah, in this way. So you can just use this dragger mode. Okay, so you can check this. So you can see in this way you can just use this dragger mode. Okay. Okay, then there are again some mouse selection modes. Okay, so first one is like if you just click on this first one, you can click on any point, okay, on the object, okay, or even in your workspace here, and it will take your robot to that location. Okay, and definitely it will take you, your robot will move to that point only, uh, till it's like reachability. Okay, if you take the point here, you can see the state here, it is red color, means it is not reachable. If you click here, so it is showing green color, means it is reachable, right? So this is one option. The second one is the, like, if you're clicking on any object, it will click on the center point. Okay, it will take you to the center point of that object. Okay, center point of this object, right? So these mouse selections are very important to give your motion program. Okay, so in the motion program, your motion program will be depend on the uh, the waypoints or the locations which you want to set for your robot. Okay, so these mouse selections are very important for this. The next one is the edge one. If you just click on any object, if there is any edge, so it will consider the edge of this object. Okay, so you can select this in this way. Okay, so here you can select, here you cannot select. Okay, And then the grid, so this will be applicable for the grid. So here there is no grid. Okay, so it will be not applicable. Again, one more thing is like you can edit the speed here. Here currently the speed is 100%. You can reduce the speed as per your robotic motion, right? So you can edit that speed. Then yeah, other options you can just explore. These are the main options which you want to see. Right? Okay, now we have to give the motion program, right? For our automatic motion. Yeah, so you can just click on this, or yeah, no need to click, just click on motion program manager here. When you just go to motion program manager, here you have to select the robot. Currently we have only one robot. If there are multiple robots, then you have to select the robot for which you have to create the motion program, right? So currently here there are only one robot available, so I will select the robot one, and you have to add the motion program. So here you can add multiple motion programs, right? So motion programs can be in any way, right? So here, like, if there is one motion, okay, you're going to robot and you want to give another motion also for the particular robot, so you can give it, but you have to make it, you have to edit it, you have to give that motion program separately, and you have to make it active anytime, so every time, right? So that that is possible. So currently I will just remove this all other motion programs, and first we will understand how the motion program is created, right? So when you just create any motion program, right? So you will get three options here. One is identification, okay, then program, and then waypoints, right? So in order to create any motion program, the most important thing is that you have to create the waypoints, right? You have to give the waypoints. The waypoints in the sense the location at which the motion should be set. Okay, so it should create, in order to create a motion, the location, like you have to create that motion, you have to choose that objects or the path from where the motion should be created, right? So here I have selected the means I have to select the waypoints here, and then here in the program you have to give the program. Okay, you have to create that logic for that waypoints, right? Okay, um I hope it is clear till now. um If anybody has any question, you can type the question in the question pane, okay, uh, or the chat box. Okay, yeah. Okay, so now we will create the waypoints. So I will first of all I will just set the, no, it is, okay. So I will just, yeah, I will make this visible. Yeah, and yeah, now it is visible to all. Okay, so now we will create the waypoints. So here in the waypoint, in order to create the waypoints, you have to click on this create waypoint. Okay, when you just click on this create waypoint, okay, so again a window will pop out. It is same as the control panel which I have opened before. Okay, it is the same as control panel only. The only thing is this add waypoint is added here. Okay, this thing is added here, right? So now I have to give the waypoints, okay, here. So first I will just create one random waypoint. So I will click on this point and I will click on this box in order to start my motion, okay, and I will say add waypoint. When I will click on add waypoint, it will ask me to name, sorry, to name the waypoint. So I will give a name as box, as this my robot is pointing to this box, okay, so I will give the box here. Then I will select this cylinder. Okay, I will select this cylinder 1. Okay, then again I will click on this sphere, right? And I will sphere, and then again I will click on this cylinder and I will click on add waypoint, cylinder 2. Okay, so my waypoints are created. So if you want to look at this waypoint, so you can see these waypoints are created here. So here in the waypoints also, you can remove the waypoints from here. Okay, you can duplicate the selection. Okay, so there was no duplicate selection here. And there are again some properties associated with this waypoint. So you can look at these properties here anytime, right? So you can expand this um, window, right? For example, and here also again, when you click on validate waypoint, so again I need to, you click on this waypoint, so you can see the robot will take you to that location. Okay, so here, 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 right? Okay, I want to create one more waypoint here. When my box, my motion will start from this box to this cylinder, this sphere and this cylinder, it should end at any home location, at any location where there is no object. So what I will do, I will select this point here. Okay, and I will create a waypoint and I will name it as home. Okay, okay, and you can see it is showing the reachability. You can check the reachability. You can check the reachability, and then again you can check the um, yeah, property associated with the waypoint, right? When you just create any waypoint, it will give you the um, like the waypoint size, right? Joint angle, okay, joint angle degrees it will show you, right? Again, the technical characteristics, control, identification, everything will be visible here, right? You can just check this. Yeah, it is similar with the other waypoints also. Yeah, so my waypoints are created. Now I have to create a program, motion program for these waypoints. So I will just click on this program. Okay, and here are different types of motions. Okay, you can see here different types of instructions also, you can call it J instruction, L instruction. If you want to go for linear instructions, you can click on L instructions. Then you can click on C instruction also. Okay, C motion. Then there is like a wait instruction, so you can give it for the gripping options if you want to give. Okay, for the suction tools, so wait instructions, and then the digital output instruction you can give it. Okay, so here I will just create a simple motion of J instructions in order to show you, right? And other motions I will show you some with the help of some example files, right? So you have to just click on this J instruction. As soon as you just click on this instruction, it will give you one pop out. Okay, so it will ask you the target point. Okay, so my motion will be start from this box. Okay, so I will select this box and I will click OK. Okay, similarly I will create, right click on this and I will give one more J instruction here. Then my motion should be here in the cylinder 1. Okay, then I will give another instruction and I will give it to sphere. Okay. Oh, okay, I have to validate this, and then again I will give one more J instruction, and it is to cylinder 2. Okay, and we will click OK here, and my last J instruction should be to home position. Okay. Okay, then again, so you can check this. I hope you are able to create these motion programs. If you are not able to create the waypoints and the motion programs, please let me know. If anybody is working on this, right, please let me know. So you can just type it in the question pane here if you have any question related to this waypoints and the program. So here again, you can just if whenever you just click on any waypoint, or sorry, the motion, you will get some instructions here. Okay, related to that motion program, you can check it, right? You can change the motion constant mode also, either by speed you want or either by duration. You can edit that also. Okay, you can change the speed percent. Again, for each and every instruction, you can change the speed percent constant, right? So you can just change it, right? And also you can change the component name, or you can say the instruction name. Okay, so here it is the move joint instruction by default, so you can name it, right? So that is totally possible, right? um if you want to view the path, now we have given a path to this robot, or motion to the robot, so you can just click on this display path, and you can just click on this. Oh no, not this, it will go to default path. Update the path. Now you can see, I will just move this. I will go to run here. I will click on motion program here, and you can see how it is moving, right? And here, if you just update the path, so you can see how the path is updated here, right? So in this way, you can just update the path here, right? And so I will just remove the path. No, I will just let it be the path, and you can just keep it on loop here, and you can start the run. Okay, motion program, you can just click on the motion program, and we will click on play motion program here, and you can see how your robot will work. Okay, so here I have not given any restrictions or the constraint to my motion, so that is why it is giving me the continuous motion, right? But you can edit it, you can give the constraints to it. I have told you how you can give it. So those who are creating, trying to create, I hope you are able to create this. If not, please let me know. Okay, so okay, so I will just stop this. Okay, and now I will just remove this path here, right? So in this way, you can give the motion program to your robot, which is very important. Okay, so here in the then we have other tools also, like we have conveyors. Okay, so we have conveyors here. So you can add the conveyors here in this way, right? Whenever you add the conveyor, you can edit the length, width, and height of the conveyor, right? If I just click OK, so you can see how the conveyor looks. Again, if you just double click on this conveyor, you will get the properties associated with that conveyor. You can add the input output tables. So in the like companies or the manufacturing units, you can see there are like input output tables on the for the conveyors where the objects will be placed, right? So you can add this output tables also. Okay, so I will remove this input output table. As I told, you can change the height also, edit the height, length. Okay, the speed also, you can edit the speed of the conveyor, right? So this was the linear conveyor. Now again, you can add the row, this curved conveyor also you can add in this way, right? Again, you can edit the parameters here. You can change the angle, you can make it to 45 degree, right? In this way you can just make the 45 degree. Okay, again here you can add the input output tables. Maybe I will make it to 90 also. Okay, so in this way, um, so if I want to add other also, you can just add it in this way, right? So if I want to add in this way, so you can make the path here, right? So you can just make the conveyor in this way. Okay, I will just move it here. it, Here you can again, like if you start the you can also add the sensors also. So if you want to add the sensors, you can add the sensors here. Okay, so in this way you can add the sensors. Okay, now you can also add the loads, right? You can add the different loads here. Again, you can change the color, right? um you can change the color here. So if you want to give the motion to it, I will go to motion program here. Here in the run, I will add this conveyors into the motion mode. Okay, and if I just start the simulation, so you can see how they are working. So in this way you can edit the conveyors. Just for a change, I will just double click on this and I will give an output table here, right? So it should move here and it should reach to my output table. So now the sensors are not linked to any other like program or the logic currently. It is just detecting the object. So you can link these sensors to your like circuits, PLC circuit also. Okay. Okay. So currently this object is not aware of this object, so that is why it is colliding. Okay, but there will be other ways also, like how you can move these objects. So this is the conveyor, right? uh, yeah, yeah. So do you have any question till now about this process, right? So are you able to select these conveyors, these sensors? Because now I will show you some examples. So with that examples, you will get a clear idea how, okay, extensively you can work on this robotics module, right? So yeah, there I can see the question from Harman. Yeah, Harman, hi. So the program of the robot is based on, actually it's currently it is based from Mitsubishi robots only, right? In this new edition, we have not, I am not able to see the Mitsubishi catalog, but these are designed with the help of Mitsubishi robots, right? So this can be linked to your Mitsubishi ladders. Yeah, pick and place operation, Mandar. I will just show you an example. I will not able to create the whole program because it will be a uh, big task. Okay, to create in this webinar. Maybe we will again give you the training on this. This is just an overview, but I will show you an example how to pick and place. Okay, I will show you. Yeah, so that is very much possible. So for the pick and place, we have the suction tool. Okay, you can use this suction tool, right? So let's check some examples of this. Mm, yeah, let me. This is a six-axis. Okay, so let's move on to our examples, right? So this is one example. Oh, sorry. So these examples are available in our demo files also on our website. Okay, so you can anytime explore these examples and you can check the motion programs of these robots. Okay, so for this now here also you can see the motion programs. Okay, so this is the pick and place which you were asking, Mandar. So it is changing the orientation of that object. Okay, so you can see how it is just picking that product and just rotating it and changing the orientation of that product. So there is different motion program for this robot, right? Now if I want to go to motion program of this, okay, so you can see different logic is there, different motion program is there, right? So maybe in later we will try to arrange a training with you all to explain it, right? Or also you can if you are using 9.0, so you can just take these files from our demo files and just explore it, like how it is created, or okay, how it is working, right? Similarly, yeah, autosave is in progress. Yeah, so this is the example of 4 axis Kara robot. Again, this is showing me the motion program of this robot. So can we perform forward and inverse kinematic motions for analysis purpose? Um, yeah, it should be possible. But I will not be able to explain it now. It should be possible, right? Yeah, Madhujit, are you aware about this question? Like, can you answer this?
Yes, the kinematic motions are possible. Only thing is the inertias and those values you need to uh, enter it in the data properties of the robot.
Okay, okay,
But the motion will be strictly as per the coordinates defined. So its path will be, as per the logic that Saurabh explained. But yes, the mass values and inertia values can be entered as per, the inputs that you have in the data properties of the robot.
yeah, yeah. So this is about the SCARA 4-axis robot, and the next example which I wanted to show you. Oh, okay. So there are 4 axes moving, changing block. Yeah, this is one example I wanted to show. Okay, so this is one example of conveyor. Okay, with the sensor. So it is, so in this example you can see the path. Okay, they have defined the path and it is visible in this, right? Okay, so an example. And the last one which I wanted to show you of this example. Okay, so I will just, okay, I will just zoom it a little bit. Maybe I will also open the ladder one. And I will make it the tile view. hmm Okay, so make it visible. And here is the conveyor one. No, sorry, conveyor, not PLC one. This one is linked to PLC. And if I start the simulation, okay. So I hope it is visible to all. So how this PLC is working, you can see this PLC is linked to this. Okay, you can see how it is working. So in this way, you can just link your robot process to your, or the conveyor to your PLC circuit. Okay. So can we connect real robot with OPC, as we have already these robots? OPC connection? No, I need to check with the OPC connection. I'm not aware of this. I will get back to you regarding OPC connection. Okay. So if you can connect a real robot with the OPC connection. Okay. So may I know which robots you are working with? The means you can tell me the brand of the robot. Okay, so you're working for Mitsubishi only. Okay, great. So I will just check with our Montreal team. Okay, if OPC compatible with the Mitsubishi robot. Yeah. Okay. Okay, so you have both, like Mitsubishi Scara and 6S it's articulated. Okay. Yeah, Yeah, so that is all from my side for today's webinar. Okay, as I told you, like this was just an yeah, so there are other robots also in development. So as I told you, with the updated versions, you will get more features into it and more robots and components. You can see currently the library is very small. You can see there are only two robots and tools, some tools only. Okay, with the updated version, you will get more and more in this robotics module. Okay, so this is we have already launched 9.0, right? So this is like we have introduced robotics in the 9.0. Okay, so there will be like in the coming months, like we will have the service releases. So we will let you know, right? You can update it accordingly. Okay, yeah. So so if there are any like developments and the improvements in the in this current version, so we will definitely let you know. We will also try to arrange some trainings with you later. Also, um, like there are some webinars. Okay, we will try to conduct more webinars on this, and we have to conduct one more webinar, I guess, for instrumentation and process control. Okay, so we will try to arrange it soon. If you have any questions related to this, you can email me the questions, right, and queries related to it. And also, if there are like certain improvements, now you will be working on these modules. So if there are some improvements you want us to do, or any feedback related to this module, so please let us know, right? Even the feedbacks from the customers, please let us know. We will convey it to our Montreal team. Okay. Okay then. So thank you very much for joining this session for this this webinar. Okay. Thank you very much. Have a good day.